This is the assignment Analysis of Vectors in Projectile Motion. And perhaps you recall this picture from your textbook. It's a picture of a cannonball being fired from a cannon, fired horizontally, but after it leaves the canyon, or the cannon rather, the ball begins dropping. So what am I going to do? Okay, so hold on a moment. Let me go on with what we're talking about here. Okay, so the cannonball is moving horizontally, and I think you can see that the blue vectors that are pointing horizontally, pointing to the right, indicate that the object is moving to the right, and those particular vectors that are pointing to the right are not changing in their length. All right. On the other hand, the vector that's pointing down is growing, which means that it's accelerating in the vertical direction. Okay, and so let me pause for just a moment. Okay, and so, whoops, excuse me. Okay, so we can pick any one of these instantaneous pictures of the cannonball, and we notice that there's an arrow that points to the right and an arrow that points down. So then what we're doing here in this graph is we're replicating those vectors. Okay, so the vector here that's pointing to the right represents the horizontal velocity, and then the vector that's pointing down represents the vertical velocity. And so what we're going to do is we're going to do the vector sum. This is the way we add vectors together. We're going to do the vector sum to add these two together to get what's called the resultant vector. So we start by drawing a dashed vertical line, a dashed vertical line from the end of the horizontal vector. We do something similar from the end of the vertical vector. We draw a dashed horizontal line. And then we can draw the diagonal of the resulting rectangle, which gives us the sum, or in other words, the total velocity of the cannonball. Right, now we can actually count here and figure out what the magnitude of that vector sum is going to be. The horizontal vector, if we count, it's 1, 2, 3, 4, 5, 6, 7 squares, which represents some kind of velocity magnitude, and that's the horizontal velocity is 7, and the vertical velocity is 1, 2, 3, 4, but in the negative direction. So the horizontal velocity is positive 7, and the vertical velocity is negative 4. So as we go down the page here, what we're going to do is use the Pythagorean theorem. A squared plus b squared equals c squared. And so you can see that we've written the Pythagorean theorem in terms of the velocities. The velocity in the x direction squared plus the velocity in the y direction squared is equal to the square of the total velocity. And so far we know that the horizontal velocity is 7, the vertical velocity is negative 4. And so we insert those into the Pythagorean theorem equation there that we have. Right? 7 squared is 49, negative 4 squared is 16. Add those together, you get 65. Okay, so that means that 65 is equal to the square of the total velocity, or in other words, the square of the total velocity is 65. And then we take the square root of both sides of that equation, and we get that the total velocity is the square root of 65. That's the exact answer. And then the approximate answer is what we get when we take the square root of 65 on the calculator. When you do the square root of 65 on the calculator, it turns out to be 8.062. Okay, so we're going to pause for just a moment, and then I'll restart. Okay, so we got the total velocity was square root of 65. The approximation, which is why I'm using the squiggly equal sign here, is 8.062. And that's what we get when we take the square root of 65 on a calculator. Okay, so let's go and take a look at some of the problems. Okay, so here we have a different situation where our horizontal velocity is 1, 2, 3. So 3 in the horizontal direction, and then in the vertical direction it's 1, 2, 3, 4, 5, 6, 7, 8. I'm counting the squares. So we said it was 3 in the x direction, but it's negative 8 in the y direction. Okay, so 3 in the x direction, negative 8 in the y direction. Okay, but now we have to calculate that to get the magnitude of the vector. Okay, so we're going to use this calculator. Let me move it over here. You know what? I wish I had made something else available to you. Nuts. Okay, usually I use the scientific calculator, but for some reason I didn't activate the scientific calculator. Well, anyway, so we won't be using that calculator. Let me do some annotation instead. Okay, so we have 3 in the x direction. We're going to end up squaring that. And then it was negative 8 in the y direction because it's 8 down. And we're going to square that. And then that is equal to, that's going to be the square of the total velocity. And I'm going to use t for total. Okay, so this is 9 plus 64. 64 plus 9 is 73. So that means 73 is the square of the total velocity. Okay, so on my handheld calculator here, make sure I get my calculator. Here it is. Okay, so negative 8, when you square it, you get 64. 3 squared is 9. 64 plus 10 is 74, but 64 plus 9 will be 73. So I'm going to take 73 and then take the square root of that. Okay, and it turns out that the total velocity then becomes approximately, I'm going to round off to 3 decimal places. So it's going to be 8.544. And you can do that on your calculators at home, right? Because the square root of 73 is 8.544. You can do that on your calculator. So I'm going to go here, and which one of them would that be? Okay, well, it turns out to be this one, 8.544. It's not negative. So always, when we get the magnitude of the total velocity, the answer is going to be positive. So that's the one that we would select, is positive 8.544. So when you get the total velocity vector approximately, your answers should always be positive. Okay, so hopefully that helps you with the rest of this assignment, and you see how to do this. Again, I've been taking a video of this, so I will be posting this video into our Schoology page.